So today's the last day to opt in for a test retake rather than taking the doubled high test score. So if you are interested in doing that, you need to send me an email ASAP telling me that that's what you want to do and what chapter test you want to do that for. If you don't want to do that, that's fine. Nothing will change because those doubled high test scores have already been entered. Tuesday at 8 a.m. is the last homework check. We're going to be looking for homeworks 5.1, 5.2, and 5.3. And then any other late work that you need to catch up on or still want to catch up on is due by that date. Make sure that you've synced your OneNote at that point. And that you've emailed me to kind of, especially if you're putting in any missing work, that I make sure that I see it. Sometimes it's hard to catch that you did something from a long time ago. Like I'm pretty good at checking that week's, but these older things that if you've added in recently, sometimes I miss those. So please, if you can send me an email to remind me to look for it, that would be great. And again, make sure your OneNote is synced. This is the last homework check. I'm not going to check anything else past that date. So it's got to be in and it's got to be right and it's got to be synced at that time. Because I'm not going to look at anything else after that. Okay. And next Friday, after exams, I'm going to delete all the shared components on OneNote with you guys. I'm not sure if that's going to delete your notebook at your end or not, but just in case you might want to move if you want to save anything in there, you might want to move it to the non-shared section. I don't think it'll delete anything on your end because I think it'll all be cached from you guys, but I'm going to clear out all that stuff from my computers to make room for the new shared notebooks from second semester. So just giving you a heads up there, but that'll just take a minute or whatever for you guys. Just reminding you that that's going to happen. Okay. Any questions about any of those three things? Okay, very good. So next up are questions from homework 2. If there's any questions from this homework 2, you can type them in the chat or you can say it aloud if it's easier to do it that way. Either is fine. Number 10, it looks like, is a popular choice. So if we go down and look at number 10. So when I look at number 10, I'm going to think about this. Well, I'm going to see that I have an even exponent on my x, and then a subtraction symbol, and then a constant. So this could be written as a difference of two squares. So I know x to the 8th is x to the 4th times x to the 4th. So I could write it as x to the 4th squared. And then 1 could be written as 1 squared. So I can do a difference of two squares there. So write as x to the 4th minus 1 times x to the 4th plus 1. And if I look at each of these, x to the 4th minus 1 is also a difference of two squares. But x to the 4th plus 1 is not. You can tell it's not because it's got a plus sign there. So I can factor x to the 4th minus 1 to x squared minus 1, and then x to the fourth plus 1 still comes along for the ride. And then if I look at each of these, again, that's not factorable. I can notice that this x squared minus 1 is a difference of 2 squares. But x squared plus 1 is not, again, because it's an addition symbol. So this is quadratic. I already know how to factor that, just like we did last chapter. So I can factor that piece. And would be my final answer. So there was 3 difference of 2 squares factorings in there that I got to do. Is that okay, Natalie and Mia? Okay, I'll assume from your silence that was okay. Anyone else with questions? Okay. So, let's kind of continue with what we've been talking about. So we've been talking about factoring polynomials. And last time we talked about 3 techniques. We talked about the sum or difference of 2 cubes. So the factoring patterns that we established there were these ones. And then we had the difference of 2. And then we had the stuff that was in the corner. Okay. And we're going to add to that list one more today. That technique is called grouping. And we've actually used this already when we factored quadratics using the long way, last chapter. So let me just pull out my examples. Okay. So let's say we have x cubed plus 3x squared plus 5x plus 15. So the idea here with grouping is we're going to make 2 groups. So I'm going to just take the first 2 things and the second 2 things. It doesn't matter what stuff you group. Typically work, but in general, just write it in standard form where the degrees decrease and then group the things together that way. I'll take common factor out of each group. From the first group, we can take out an x squared. From the second group, we can take out a 5. I notice then each term has a factor of x plus 3 in it. So that's also a greatest common factor. And when I factor that out, I'm left with x squared plus 5. And then I should check to see if I can do any more factoring. So x plus 3 is linear, so I know that can't factor anymore. And x squared plus 5 I know can't factor anymore because there's no sum of squares factoring pattern. So this is as far as I could go on that. Let's do another. So let's say we have x cubed plus 4x squared minus 9x minus 36. So again, I'm going to make my two groups, but one of the things I have to remember is in between my two groups I need to have a plus sign. So instead of thinking about that as subtracting 9x, I'm going to think about it as plus and negative 9x. Greatest common factor in my first group is x squared. The greatest common factor in my second group is negative 9. I notice there's an x plus 4 in each term, and when I factor that out, I have x squared minus 9. Then I should check to see if I can factor any more. Obviously x plus 4 can't factor anymore because it's linear. But x squared minus 9 is a difference of two squares. So I could factor that some more. But there's not much to do with that. It's just like something we'd have done last chapter. And now everything is linear. So I know that there's no more factoring I can do there. All right. Let's make a little summary here. So the first thing we'd look for, if we're factoring, is just a greatest common factor. And then what we'll do next would depend on the number of terms in our polynomial. If I have two terms, the first thing I would check is for a difference of two squares. If that answer is yes, I'll factor it as a difference of two squares, and then we'll go to the two-term box. If the answer is no, then we'll look for a sum or difference of two cubes. If the answer is yes, we'll go back up to the two-term box. If the answer is no, we're going to stop. The other option is if we have three terms. So if it's three terms, we're going to check to see if it's in the quadratic form. If the answer is no, and we stop because it's not factorable. All right, sorry about that. Okay, so we were in the checking if it was in the quadratic form. If it's no, then we stop. If the answer is yes, we're going to look at the leading coefficient. The leading coefficient is 1. We're going to try the short factoring. If we are able to factor with that shortcut, then after we factored, we have to check the 2-term and run through that branch. If we're unable to factor with the shortcut, we stop because we're not factorable. If the leading coefficient is not 1, we have to do the long way. If we can factor the long way, then we need to, after we factored it, check the results through that 2-term branch. If we're unable to factor the long way, then we stop. And our last branch of the tree are for things that have 4 terms. Here we want to check to see if we can use factor by grouping. If we can't factor it by grouping, it's not factorable, so we can stop. If we can, after we factored it by grouping, we have to check it through the 2-term branch. So this is if we're going to be able to factor this, or factor a polynomial using the methods we've been presented here. This is the process. Notice that there's a bunch of things here that are not, that we can't deal with, right? So if we have 4 terms that we can't use grouping, we can't factor those, or we don't have a method to factor those right now. If we have 3 terms that are not in the quadratic form, we don't have a method to factor that. And if we have 5 or more terms, we don't have a method to factor that. All 3 of these things we're going to address second semester. So we are going to fill in some blanks in this little summary and be able to add to this procedure a bit more, but it's not, it's not trivial, the amount of work we'd have to do that. So that's going to be left to second semester, but that'll be one of the first things that first new things that we tackle in second semester is expanding this procedure so that we're able to do with that, or to deal with that.
Mr. Kolek?
Yes.
Ella's computer is restarting.
Okay.
So it kicked her out.
I understand. I just got dropped also, so.
Okay. That's all I'll let you know.
Thank you. I appreciate that. Okay. So let's talk about solving here now for a brief minute, and then we'll do some examples where we combine these two ideas to practice a little bit, and then we'll be done. So solving polynomials. First step is we got to get it so that it's equal to 0. Second step is it needs to get factored. And then we'll use the third step, will be use the zero product property to set each factor equal to 0. And then our last step would be solve each factor separately. So very, very similar to what we did with the quadratics. The one drawback here is that polynomials cannot be solved directly, and there's no closed form formula to solve a polynomial. Now, it's not just that nobody's invented this, but we've actually proven for polynomials of degree 5 and higher, it's impossible to create like a closed form formula. Like you can't create a quadratic formula to do that. Okay, so let's do a couple of examples. So this will be both practicing the solving and practicing factoring, because we have to use factoring to solve all these things anyways. Okay. So I'll just do a couple of examples here. Okay. So we have 8x to the fourth plus 8x cubed minus 27x minus 27. So the first thing I'd want to do is get it equal to 0. Well, it's already equal to 0, so there's nothing to do there. Now, the next thing I'm going to do is try to factor this. So if I go up to my factoring diagram here, or my summary, the first thing I'm going to look for is a greatest common factor. Well, there's no greatest common factor in there because there's nothing in common between 8 and 27, and not all the terms have an x, so there's no greatest common factor there. So then we'll look at the number of terms. This particular problem has 4 terms. So if it's factorable, we need to use grouping on it. So let's go back and try to factor that by grouping. So I can take a 8x cubed from the first group, leave me with an x plus 1, and a negative 27 from the second group, also leaving me with x plus 1. Because these parts are identical, we know that this is factorable by grouping. That's what we need to have to continue our factor by grouping. So now I can take the x plus 1's out, leaving me with 8x cubed minus 27. So if I go back and I look at my diagram, we were able to factor by grouping. So now we need to go to the two-term section and check each of the factors, because they have 2 terms in them, through that two-term section. So the first thing we're going to look for is a difference of 2 squares. Well, x plus 1 is linear, so that definitely isn't going to fit it. And so the next thing after that, I would check to see if it's a sum or difference of 2 cubes. Obviously it's not because it's linear, so there's no more factoring I can do with this. So now we'll check this factor. It's obviously not a difference of 2 squares because the exponent is to the third. It's an odd number. So we'll check then if it's a sum or difference of 2 cubes. There I notice that it is a difference of 2 cubes. 8x cubed is 2x cubed, and 27 is 3 cubed. So I can factor that some more using my difference of 2 cubes factoring pattern. So I do a minus b times a squared plus a times b plus b squared. And then I should simplify. 2x times 2x is 4x squared. 2x times 3 is 6x. And 3 squared is 9. And I don't have to worry about checking this quadratic piece to see if it's factorable, because one of the features of this sum and difference of 2 cubes factoring pattern is the quadratic piece that you're left with is never factorable. So I don't have to worry about that. So now I can move on to solving. So to solve this, I'm going to apply the zero product property, which allows me to set each of these factors equal to 0. So I can solve each one of these separately. So to solve x plus 1 equals 0, I'll just subtract 1 from both sides. To solve 2x minus 3 equals 0, we'll add 3 to both sides, and then divide by 2. And then to solve 4x squared plus 6x plus 9, I can't solve this directly because I have both x squareds and x's. And I just established that we can't factor it. So to solve this quadratic, I have to use the quadratic formula. So negative b plus or minus b squared minus 4ac all over 2 times a. So 6 squared is 36, minus 72 is negative 36, and 2 times 4 is 8. The square root of negative 36 is 6i. And I notice that 6, 6, and 8 all are divisible by 2. So I can simplify this to 3 plus or minus 3i over 4. Further worth noting, again, this quadratic piece that comes from our sum or difference of 2 cubes, not only is it not factorable, but its solution will always be imaginary as well. So that also worth pointing out there. Okay. But notice the solving part was really not any harder than the things we did last semester, right? Now we had more solving problems, but the hardest solving problems that we're going to have are solving quadratics, which is just what we got done doing. Which is part of the reason why we see that the quadratic was so important, because many of these more complicated problems just break down into solving quadratic parts. Let's look at another example. Let's say we have x to the 6th minus 9x to the 3rd plus 8. So again, to solve this, the first thing we want to do is get it equal to 0. Already done. Nothing to do there. So the next thing I'd want to do is try to factor this. So if I go to my factoring diagram, first thing I'm going to do is look for a greatest common factor. There's definitely not one of those. So then if we go look at the number of terms, we have 3 terms. And then we need to check to see if it's in the quadratic form. So let's check that. So the easy way to check if it's the quadratic form is if I look at my biggest exponent, should be double the next biggest exponent, and I should have a constant term. which is exactly what I have, so this is in the quadratic form. So let's try to factor it. The first thing I'm going to do is try to write it as a quadratic. So I know x to the 6th is x cubed squared. And then x cubed I can write as x cubed to the 1st. And if I make a substitution then and replace my x cubed with a y, I have something that is absolutely quadratic. And since the leading coefficient is 1, I can do my shortcut factoring. So I just need to find two things that multiply to give me 8 and add to give me -9. That would be -8 and -1. But remember, we're not solving for y, we're solving for x. So now that we've factored this, we've got to put those x's back in. And then let's go back to our diagram and look at where we're at and what we need to do next. So if I go back up to my diagram here, I was able to factor, it was in the quadratic form, its leading coefficient was 1. I was able to do the shortcut, so now I need to check each of those factors through the two-term section. I had x cubed minus 1 and x cubed minus 8. Since they're both to the 3rd power, neither one was a difference of 2 squares. So then I'm going to check if there is sum or difference of cubes, and they are both differences of 2 cubes. So let's factor them that way. So here, my a is x and my b is 2. And this one, my a is x and my b is 1. So when I factor them using my difference of 2 cubes formula, I have a minus b times a squared plus a times b plus b squared. And then the next one, I have a minus b, a squared plus a times b plus b squared. And if I clean this up a little bit, okay. And then I should go ahead and check these two-term pieces to see if I can factor them anymore. They're both linear, so I know I can't factor them anymore. They're not differences of 2 squares because they're not to the 2nd power. They're not sum or differences of cubes because they're not to the 3rd power. So we are done factoring. We can then use our zero product property to set each of these pieces equal to 0. And we can solve each one of them separately. So x minus 2 is equal to 0. That's easy. We'll add 2 to both sides. And x minus 1 is equal to 0. That's easy. We'll add 1 to both sides. The x squared plus 2x plus 4 and the x squared plus x plus 1 are both quadratics that came from a sum or difference of 2 cubes factoring. So I know the only way to solve them is to use the quadratic formula. So negative b plus or minus b squared minus 4ac all over 2 times a. And 4 minus 16 is negative 12. And I know that the negative makes an I. The square root of 12 is the square root of 4 times the square root of 3. And the square root of 4 can just become a 2. And the square root of 3 is just going to stay the same. And then because everything has a factor of 2 in it, we can reduce and there's our answer. Similarly, we'll do the same thing with x squared plus x plus 1. So negative b plus or minus b squared minus 4ac all over 2 times a. 1 squared is 1, minus 4 is negative 3. And since I'm squaring a negative, I make an I. The square root of 3 can't be simplified anymore. So we're done right there. So those are my answers to this one. Okay. Questions so far? We'll do one more example and then call it a day. So this would be, I think, example C. Let's say we have x to the 8th minus 256 is equal to 0. So again, the first thing I want to do is get it equal to 0. It is. So now we'll start factoring. The first thing I do is I look for a greatest common factor. Well, clearly there's none because the first term is just x's and the second term is just a constant. So then we'll go and look at the number of terms. I have 2 terms here. So the first thing I'm going to do is look to see if there's a difference of 2 squares. And there is. X to the 8th is x to the 4th squared. And 256 is 16 squared. So I can write this as x to the 4th minus 16 and x to the 4th plus 16. Oh, I shouldn't have done this one. Equal to 0. I'm going to change this problem. I don't want to get into this. I can't make it this big. We're going to make it x to the 4th minus 16 itself. My apologies. This was going to get into something I don't want to get into right now. The issue is this x to the 4th plus 16 and how to factor that, or how to solve that, because we have something that's not quadratic that we can't factor anymore right now, so I don't want to get into that. So let's just turn it into this problem. Still a difference of 2 squares. So I have x squared minus 4 and x squared plus 4. And then x squared minus 4 we can factor some more. And I know x squared plus 4 we can't factor anymore because it's a sum of squares. And obviously none of these are differences of 2 cubes, or sum of 2 cubes, because they all have, or linear or have even exponents, so that's done. So now we can just set each of these pieces equal to 0 and solve. Adding 2 to both sides. Subtracting 2 from both sides. This one I can solve directly since I have just x squareds. So I'll subtract 4 from both sides. Square root both sides. Because I square root of both sides, get a plus or minus. Because I'm square rooting a negative, I get an I. And then square root of 4 is just 2. So I have plus or minus 2. And that's that. Final questions here about these last set of topics. Okay, that's fine. Your final homework assignment here is in the content library. It's homework 3 that just has 10 of these solved by factoring problems. So they're kind of all jumbled up and mixed up in there in terms of which methods to do. But if you just kind of follow that diagram that we set up, you should be able to factor each one of these enough so that they're solvable. My suggestion to you is to try to make sure they're factored as much as you possibly can, because the solving gets easier the smaller things get. But that'll do it for today. If there's any final questions about things, I'm happy to stay and talk about stuff. But as far as I'm concerned, it seems like it's about ready for you guys to go. So if you want to type bye into the chat, you can head out of here and get to work on this final homework assignment for the semester. Have a good weekend. We'll see you guys on Wednesday next week for the assessment period. There's nothing to do there unless you're opting to do the retake, but you do need to show up for attendance purposes and just for me to say Merry Christmas and all that stuff. Okay. So the only people doing anything on Wednesday will be the people doing their retakes. Everyone else will just have a nice semester, or I'll say Merry Christmas to, and have a good semester, and make sure everything is kind of figured out, and we'll be done for the year. Okie dokie, kiddos. Have a good weekend.